Hi, I'm Rashad Mitra, a student attending Georgia Tech. Today I'll be presenting about a paper facilitating conversational interaction in natural language interfaces for visualization. This paper was done in collaboration with Arpit Narachanya, Alexander, and John Stasko. There are a growing number of systems that provide natural language interfaces for data visualization. Recently, natural language toolkits have shown promise to enable visualization developers without NLP experience to create these natural language interfaces. Consider one such toolkit, NL4DV. Given a tabular dataset and a natural language query, NL4DV automatically infers data attributes and analytic tasks from the query, and also generates a list of VIS specifications for visualizations relevant to the input query. However, NL4DV and other toolkits like it currently support one-off standalone utterances and offer minimal capability for follow-ups that will modify the existing visualization. An example of such follow-up queries could be replace budget with running time or group by genre. Thus, the end user has to ask longer queries to accomplish more complex tasks. So, we introduced such conversational interaction capabilities into NL4DV. A new conversation manager helps manage follow-ups for multiple queries, and a new query resolver module helps fix errors and resolve ambiguities. With these new additions, the complex queries shown previously can be broken down into three components, and by adding some more natural language syntax, we create more manageable queries, and in the end, while still outputting the same result as before. We demonstrate NL4DV's conversational interaction capabilities through three example applications: a Vegalite syntax learner, a mind mapping application, and a conversational chatbot. Consider the use case where a user wants to learn Vegalite. A Vegalite differential editor can show users how to write certain aspects of Vegalite specs, such as the transform or aggregate properties. For example, in this first query, NL4DV generates a scatter plot with budget on the y-axis and gross on the x-axis. If the user wants to apply a filter but does not know how to modify the Vegalite syntax, then they can put something like now show only action movies in the input field. NL4DV will output a new visualization and Vegalite spec. NL4DV highlights the newly added transform object in green. Next, the user may want to add content rating to the visualization to observe how the visualization changes. NL4DV will highlight the newly added color object in green. So the first query follows the same procedure as NL4DV, where developers can use a single function call to identify attributes, tasks, and visualizations. The second query shows a modification to the function call, where developers can pass in the parameter dialog is equal to true. This tells the toolkit that the incoming query is a follow-up, so the previous visualization elements are modified to incorporate the new query's changes. Mind maps are used to organize ideas in a tree-like manner. NL4DV can now support users to organize their conversations with a dataset like a mind map. Users can create multiple conversations through this mind map application. Users can also follow up on the same query multiple times, creating what we call conversational branches. In the backend, all queries are stored in a dictionary, a list called all dialogs. The first query will always be considered a standalone and have a dialog and query ID of 0. If the user asks another one-off query, then the dialog ID will be incremented and stored as a new key in the dictionary. If the user asks a follow-up to the previous query, then dialog ID will remain the same while the query ID will be incremented. As a result, the JSON for this query is appended to the dialog ID 1's list. If the user wants to ask a follow-up to the initial query of a conversation, then a new dialog ID is generated corresponding to the initial query's dialog and query ID. The last integer represents the branch index of the initial query that helps uniquely identify the conversational branch. This branch index is incremented as and when new branches are added. Natural language is often ambiguous, containing phrases that may have different meanings within the context of the query. For example, in the query show me medals for hockey and skating by country, by medals, does the user mean gold medals, silver medals, bronze medal, or total medals? The chatbot detected an ambiguous keyword, medals, and presented a widget for the user to resolve. It also presents widgets for the words hockey and skating. Once they have all been resolved, a visualization is finally recommended. The user can then continue the discourse, for example, choose to follow up on the previous query or ask another query. Consider that the user follow-ups on the previous query by asking group by sex. It retains the ambiguity selections that the user made from the previous query, speed skating, total medal, and hockey, and outputs a new visualization that adds the attribute sex to the visualization. Internally, NL4DV stores these ambiguities in a dictionary where the keys correspond to the type of ambiguity. Each ambiguity key has its own separate dictionary where the keys are the ambiguous keywords and the values are the keyword's potential options. To resolve ambiguities, developers make a function call with an input dictionary that contains the user selection for each keyword. NL4DV subsequently updates the underlying data structures. In this way, NL4DV introduces conversational interaction for NLIs for visualizations. NL4DV is available as open source software at this link, and we hope that with conversational interaction capabilities, it enables prototyping even more powerful natural language interfaces for data visualization. Thank you.